All right, so are they congruent? Why or why not? So you can write it down and think about it in here. Oh yeah, there's a typo. Yep. I always forget my retakes are. Tough. All right. I'll give you like a minute to think about that. You should know it pretty quickly, but I'll give you a minute. Oh, somebody beats to it. No. You can go after Leslie. Beat you to it today, Jessica. Where is my minutes? Huh. Grades are pretty much up to date. All the retakes are in. Although I haven't like looked through to make sure. I don't think I have any left in my backpack. I think they're all in. So whatever your grade is at right now, that's pretty much your final grade. I don't think there's going to be any new grades. So there you go. Yeah. So the only way after, well, yeah, actually the only way to change your grade, because I don't think I'm putting this week's quiz on this quarter. It'll be the first grade of next quarter. Well, because if I do, there's not going to be any time to do a retake. So you'll be stuck with it. So if it's bad, there's no changing by the time I get it graded. Because you wouldn't take it until Friday. By the time I get it graded in, I'm not taking it anymore after the 21st. You have like 2 days to do a retake. So yeah, so if you need to change your grade, you have the two that say December, well, technically, I guess proofs you can still do today by the end of the day. That's final after today. You can then do parallel lines, transversals, distance between 2 points up until the end of the day on the 19th. And then the one we just took, which was that solve for angles and triangles, and then congruence in triangles. You can do that one till the 21st. There's all other retakes 21st. So that's the two you can do until 21st. So really just those 4 grades are all you can do to change your grade. Not many people have been coming in any way, so I guess we can just start going over this. I'll do attendance later. What do you think? Congruent or not congruent? Why? What's the concept? Say what? Well, if we could somehow do that, then you might be able to come up with it, but they're the ones we learn. What do we learn? Like the theorems that allow us to say triangles are congruent. Let me ask you this. Is that side, side, side? Is it? Do you see a third side, Mark? Can't be side, side, side. So what was the other one we learned? Side, angle, side. So let me finish doing attendance real quick. Al's not here. Raise your hand if you were not here Thursday of last week. Do you remember that? So you guys missed the lesson. So I'm going to do a super fast review of that. Kind of goes right into what we're doing today, though. Here. Maria. Aiden. Here. Here. All right, see you guys. I shall see one of you later. Yes. Phone should be up. Yeah, that's for you. God, I just said phone's up. Literally said that would be you. Sophia's time is different. Mars here, breathe. All right. All right, so when it comes to congruent triangles and proving they are congruent, so this is different than solving. If you already know they're congruent, that's a different lesson. That was this lesson. If they're telling you the triangles are congruent, then that's when they give you that statement, and you just then use that information maybe to solve for a variable. If they're giving you markings in the entire triangle, so like they're telling you like this, 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 and they're doing all these more like these things, although that does have to be. So if they're giving you markings on the entire triangle, then you can say that they are congruent because of the marking. You don't really need a theorem. It's just if every part of the triangle is congruent in one triangle to another triangle, then they're congruent because every single part, if every single part is congruent, then the triangle has to be congruent. Oops. I think it's right. So what we've moved into now is if you only have a little bit of information about congruent sides or congruent angles, there are still 4 ways to prove that any triangle is congruent, even if you don't have markings in every single angle and in every single side. That's what we're doing now. You just have to memorize those 4 ways. Oh, so if you didn't hear, okay. There. So for this particular triangle, one of the ways, for those of you that were not here, one of the ways to prove it is if we said, well, I have an angle and a side and an angle in that order, has to be in that order. Phone up, Esteban. That would prove the triangle is congruent. So we said, all right, well, I do have an angle here, right? So that's good. Nobody corrects me. That's why I worry about you guys. Side angle, side. That's what we do. We're doing angle, side, angle today. So if I had a side and then an angle and then a side in that order that were congruent to each other, I could say that the 2 triangles are congruent. Even though I don't know anything about the other angles in the other side, that's enough information to say the triangles are congruent. So basically, there's no other way to create a triangle. If I start out with this top half, so let's say this part of these triangles doesn't exist yet. All I have is what I've started to draw there and what I've started to draw here. And so far, I've drawn everything the exact same. The angle was the same. And I'm going to make these 2 sides the same length. So wherever I stop, like wherever I stop drawing on one triangle, I'm going to make the other 2 sides the same exact length. All they're saying is there's only one way then to finish the triangle. And that would be to connect the 2 sides once you stop drawing. So if I decide to stop and make this a length of 5 and this a length of 6, there's only one way, and then this would have to be a length of 5 and that would have to be a length of 6. There's only one way to finish that triangle. I just draw a line from one end to one end, which means it's got to be the same length in both triangles, and which creates the same angles in both triangles. That's all this is really saying. Oh my God, do I really have to just say we're never going to touch a phone with this one? I've said it if I say it to one more person, we'll do what I do in my second period Algebra 1 class, 1A even. You will never touch a phone. They sat here for 20 minutes after their quiz, twiddled their thumbs. Some of them play hanging. I mean, I try to give you guys more leniency, but when I say no phones, no phones. Be different if y'all had A's in here, but you don't. Almost none of you do. Like we got more S than we got for any grade in this class. So you're lucky you ever see a phone in this class. I can fix that. Again, that's what the concept of all four of these things are. If you don't understand what I just said, just memorize only four. Memorize all four of them. There is a separate one for right triangles. But if you memorize all four of them, if you understand, it doesn't matter what's to the left or the right. So we said if I have the angle here, if I went clockwise to the left from that angle, so clockwise, I hit the side that has 2 tick marks. Well, here, I hit the side that has 1 tick mark. But we said, for those of you that were gone, it doesn't matter. Does not matter left or right, clockwise, counterclockwise, because I could flip this triangle over and then it would be like set up the correct way to where everything would match. So don't worry about left and right. All you need to know is that there is an angle surrounded by 2 congruent sides. Think of it as surrounded by. And when you do the other ones, you'll think of it as surrounded by also. Don't think of left and right or clockwise and counterclockwise. So that one is, so this is one, I'm not going to go over every single well, actually, I'm going to go over the 2 new ones, but the other one we learned was side, side, side. So if you weren't here, if all 3 sides are congruent to each other. So if you had markings like that, they don't necessarily have to all be different lengths within one triangle, but that's normally how you see it drawn, probably when it started out. Again, doesn't matter which sides are the left or right, although in this one they already match up. All you need to know is all 3 sides have a matching congruent side in that other triangle. Order does not matter which one's to the left, which one's the right, because we can always flip the triangle. So if you have that, that is called side, side, side. That proves this triangle is congruent to that. If you, well, I'll do that when I get to class. This, all you need to know. How are those sides congruent? Or why does that make both triangles? Oh, no. Sides are congruent because I told you they will. They will tell you that. Like in the figure, they will put these markings. These markings mean that side is congruent to that side. And then that's what the other markings mean. This side with 2, I'll make different shapes, is congruent to this side. And again, the markings will be there. That's the only way you know is because the markings are there. And then this side, I'll make a triangle, is congruent to that side there. If you have that, because of this theorem that's already been proven, like you don't need to question it, it's been proven, that means, and there is a way to prove it, which you probably will see something like that on the midterm. They'll probably give you some kind of a proof where you have to prove that this is true. I'm not doing that. I told you we were done with proofs. I'm going to stick to that. But just know that the district midterm is going to, I would almost guarantee, have a bunch of proofs. So again, don't worry about which one's to the left of which side's to the left of which side or the right of which side. All that matters is that they have a matching congruent side in the other triangle. And this is only for triangles. We'll do a right triangle probably tomorrow, and that's got its own additional rule that you can use. So those are the 2 we learned for those of you that were gone. Side angle, side, and then side, side, side. You want to pull your pages out. I'm going to very quickly show you the new ones we're learning today. It's same exact concept. It's just different combinations of the sides and the angles. We are on, so it's proved, now we're going to prove triangles congruent using these 2 theorems. Angle, side, angle, and then if you have angle, angle, side, you can also prove congruence. 303. If you don't have them, then just follow along. I think what it's going to boil down to for all of you is we're not going to be able to get to a real deep understanding of this in the amount of time they give us to spend on it. So you're just going to have to memorize the different. You memorize them. That is, for this particular topic, the best I think we're going to be able to do, given that they give us like one class to do it. Some of them, they don't even give us a full class. I am going to go over the proof in a minute, but for now, I'm just going to go back to my little smart notebook thing. So if we wanted to prove angle, side angle, it'd be something like that. That would be angle, side angle, or again, angle, side angle. The concept of left to right doesn't matter. Think about, do I have a congruent side surrounded by two congruent angles? So think about surrounded by, like we did when we did side angle side, only now it's kind of the reverse. To the left of this, I'm looking at it this way, to the left is one tick mark, but to the left of that is two. Doesn't matter. Flip the triangle over, and then it would be the exact same orientation. All you need to think about is this side surrounded by two congruent angles. Doesn't matter if they match up. Well, yes, it is. That side is surrounded by two congruent angles. So therefore, we have angle, side angle, angle. If you have that, then those are congruent triangles. You don't need markings anywhere else. That triangle. Any questions on that? Again, if you're not understanding why, it's one of the few times where I'm going to tell you don't worry about why. Memorize these different ones. We'll do some proofs and I'll go through a little more stuff that you might see on a midterm, but I'm not going to quiz you on it. So the last one we have to learn, at least that works for all triangles, is if we have this angle, then side. So angle, then side. So now it's not really surrounding it, so you got to be a little careful. We can't say that these angles surround the side. You just have to think, okay, do I have two angles in a row and then a side right after that? Doesn't matter the direction. It could have been two angles in a row going the other way and then this side. Like, I didn't draw it that way. I guess I could. There. Now it's the angle side going to the left. Now it's the angle side going to the right. Doesn't matter. Two angles in a row that are congruent in the other triangle, and then followed by a side. Doesn't matter that this second angle in here is like has the two tick marks versus, well, I guess it does over there too. This would have been fine as well. Because I could always flip the triangle over. Oh, actually, no, that wouldn't work. Time realizing why that doesn't matter. Think about that one. When we do the IXLs, we'll kind of figure it out for sure, but that would matter. Don't have, because if you flip it, that angle is, even if you flip it, that angle is still always going to be next to that side. So flipping it doesn't fix it in this one. But I don't think there's anything that has to do with it. It's about how you can draw the rest of the triangle. That's what it's about. Kind of like what I did there. If I erase this angle and this side, there's still only one way to draw the figure, and they would still have to match up, I believe. But I'll look into that to see if that matters. I think it's supposed to matter. So we'll come back to that. You're going to practice some IXLs on it, so it might clarify itself. But I'll follow back up with that when we kind of put all these together along with the right angle thing. So that'll be, for you guys, that'll be tomorrow and Wednesday, over 2 days. So I'll make sure we're clear on that. But I don't think it's supposed to matter, but boy, I'm sure I'm having a hard time explaining why it doesn't matter. All right. Oh, so that would be angle side is that. So there are 4 of them you need to know. Again, just memorize it. And until I give you clarification on this, just assume it doesn't matter where the tick marks are, if this one's 1 and that one's 2, or that one's 1 and that one's 2. So there's angle, side, the 2 we did today. Angle, side, angle. And then the ones we did Thursday. Side. And that's all of them that will work for every triangle. There's another one we'll learn tomorrow that's specific to right triangles. But for now, any triangle, if you have one of those 4 situations, they give you enough information to say, yes, I have one of those 4 situations, then they are congruent triangles. You are third in line. That way you want to avoid. Think about it. Would that mean congruent triangles? So Esteban just asked me, will angle work? So let's say I have those 3 angles here. Actually, here, we'll get rid of everything. So if you didn't copy those down real quick, SSS, SAS, AAS, you'll notice that there is no profanity in that, right? That one is not a way to prove congruence. You know what I'm talking about? There's a 3-letter word that would be a profanity word. That's not a way to prove congruence. So if you're trying to memorize these, make sure you remember that there's no profanity in them. Not the way they're set up. At least you could rearrange one of them. But yeah, that angle side is not congruence. Neither is angle, which we're about to talk about right now. Very good. So now let's say we have, my board was already messed up again. So now let's say we have those, and let's say those angles are the same. All 3 angles are the same. Does that mean that the triangles have to be congruent? Well, you better say no, because I just told you the only 4 that mean they have to be congruent, and that wasn't one. Here's how you would think about it. If I take a triangle, there we go. So if I take that triangle, if I do that, I didn't change anything about the angles. Those are the exact same angles. I made them smaller, like the angles, the sides came in, so the angles got, I guess you could say, closer to each other, but I did not change the measure of any of those angles by shrinking it down. That's why angle doesn't. Because you can change the length of the sides to keep all 3 angles the same. This we actually get to when we talk about similar triangles. So angle will prove that triangles are what we call similar, which means you can enlarge it or reduce it, and then it will match the other triangle, but they aren't congruent necessarily. All right, so go ahead. Oh, shoot, I'm going to show you one proof, then I'll let you go on. So look at the proof on that actually, we'll do 2 proofs real fast. Look at the first proof. It's already done. This is one you should be able to do if you get this on a midterm. No. So, not until I do these 2 proofs. You got to see these. So, I know, it's disgusted with me, but I'm only doing it because I care about you. So, in this particular proof, you should know what a bisector is. A bisector, so I'm just going to give you the short version of this. You can look back at it. A bisector, which is this line is bisecting AE, which is the one that cuts left and right. Well, a bisector, which you should know, means this length is the same as that length. It cuts it in half. You should know that. Like if they give you this in a list of multiple choice, you should have been able to say, well, I know these 2 have to be equal because it tells me that they're bisected. Well, that's the definition of a bisector. I would expect you to pick that out. Vertical angles, you should know that. It tells you this angle is congruent to that angle. Well, you should know that. There's an X in the figure. That's a definition of vertical angles. So that's a, oh, and then this would be the only one that is brand new that might be a little tricky if you had to fill that part in. But now that you know there's only 4 ways to prove triangles are congruent, you should be able to pick out the correct, because I'm sure they would give you all 4 ways and you just have to pick out the right one. Well, you just match up angle, side, angle. So angle, side, angle, angle, I'm sorry, side, angle, side, side, angle, side. Oh no, it is angle, side, angle. Oh, I'm sorry. Yeah, angle, side, angle. Sorry. Angle, side, angle, and then angle, side, angle. I should have put 2 tick marks. I didn't notice the other angle. So my guess, again, I have no idea. My guess is the only choices you'll have to make here are between the 4 types of theorems that can prove triangles are congruent. So that wouldn't be too tough to pick the correct one, I hope. You just got to see which reason matches the sides and the angles you have. They're congruent. We'll fill the last one out together real fast, then you can start practicing for a minute. Should have about 10 or 15 minutes, so yes, I do want you to practice. All right. If it's given for the reason, you know what this should be. What is that? What's the given statement that we would write there for the first statement? I'm going to go with Jenny. What's the given statement? All you gotta do is look at the first given statement. See it? Right here, if you can't see it. What's that thing in the middle mean, though? What's that symbol between those mean? Right. It means, so if you see that symbol, that's parallel. You know what that means, because that's important to this figure for sure. So our first statement is that basically it's saying what is it, W, X, Y. So it's saying the top and the bottom lines, the 2 left and right lines are parallel. The next statement is telling you that I think W, Z, and X, Y are parallel. So I don't even think that comes into play, really. I don't even think we needed that when we did earlier, but it's telling you that they're parallel also. So what's the reason for that? Jessica, what's the second reason? It's also given. Yeah. So both of the first 2 are given. So remember, that could be an easy one for you, the given stuff. It might be the first 2 lines. It might just be the first line. Now it's telling us that these angles here are the same. Why are those 2 angles the same? On to that. David, can you tell me why those 2 angles are the same? But we don't know anything about the angles. All we know is that there are some parallel lines. When do we use parallel lines? Maybe parallel lines with a figure that look like that. So what did we say is true in that kind of figure? Because that's basically the figure we have. We're just erasing the extra bit of line. That is what this is going off of. What were the concepts we had in that? No, that's about a triangle. Anybody know? I want to make sure you have some practice. Anila, any idea? Anna, any idea? All right, this is the kind of stuff you're going to see on the midterm. I'm not going to do proofs, but the midterm is probably, for a lot of you, the midterm will be a bigger grade than anything else you do in this class. We said if we have alternate interior angles or alternate exterior angles, they're the same size angle. If you have 2 parallel lines cut by what's called a transversal, it forms angles that there's really only 2 different measures, we said. So those are alternate interior. So this is alternate interior angles. The next one is, oh, my board's messing up. So next one is also alternate interior angles. So it's the same concept. We just have to pick the other two angles. So it would be WZX and then ZXY, we would say. My board is getting worse and worse by the second. So wrap it up. So those are alternate interior angles. You should know what alternate interior angles are also. Certainly, if they give this to you, you should be able to figure out which angles. Coming up with the reason part is a little tougher, but and then reflexive. What did reflexive mean? This is what I told you was gonna. Actually, no, I didn't tell you. I'm telling you now. This is gonna show up a lot when you're doing congruent triangle. What does reflexive mean? I used it when we did the proofs the other day a couple of times. I said this is a common feature when you have when you have congruent triangles. They'll give you one figure that has both triangles in the one figure. All right. It means that they're sharing a side, basically. That side is the same side for both triangles. So it has to be equal to itself. That's what reflexive is. So ZX equals ZX. Well, congruent to, I should say. Those are some easy ones. Oh, and then the last one, you would just have to figure out, well, why are they congruent then? Well, I have an angle, I have a side, and then we said which angle? This angle. So I have an angle, side, angle. All right, go into your IXL. I at least want you to see what the IXLs are and which ones I think are important. I mean, I wrote them up too, but there's a bunch of them. I would say two of them are the more important ones for sure, though. Oh, shoot, it was already in there. Never mind. I think I already put it in here. Yeah, here you go. All right, so I believe I really haven't looked at the individual ones. I'm just going based off the name for right now. I'll certainly look at them as you guys practice. I think you're looking at these two. I might even make one of these a minimum grade since they have everything in one IXL, at least for this lesson. Those two incorporate every type of theorem into one IXL. I'm not sure how they're different. I don't know why they have two separate IXLs with everything in there. This might be more about proofs. Oh, I'm sorry. This one's more about proofs. This one, I don't know what that one's going to be about. So I'll look into those and then I'll see which ones I like the questions more. That'll be the most important one for sure. But go ahead. I would start maybe with the basic ones today. If you weren't here the other day, you may want to start with this one. If you were here, I'd start with that one no matter what. The bottom two. So BVZ and 48Q. I'm gonna do attendance real quick. Did I do attendance? I did attendance.
You keep marking me absent every fifth period. You fix that?
No, I don't mark you absent.
You do. Because I get called every day home saying that I was marked absent.
How could I not mark you?
I'll fix it in the system because all we can.
I don't fix it. I can't fix it once I submit it. Done. I can let them know to fix it.